which is big C. So you're probably going to need a calculator for that one. So let's get our beloved calculator, surely one of the best inventions of the last 60 years, the personal handheld calculator. So square root 17.4 squared plus 18.3 squared, take away 2 times 17.4 times 18.3 times cos 38 equals 11.65. So there we go. We get C is equal to 11.65, and everything we're dealing with here is in centimetres. So there we go. That's an example of when you've got the two sides and their included angle, we can find the third side. That just leaves this scenario here for us to do in a final example today, where we've got three sides and we want to find an angle. So, cos rule example number 2. Right, might use a couple more colours this time. Almost feel like doing a weird example of it, but let's see if that works. All right, so we're going to give our three sides here, make this 19 metres, make this 14 metres, and we'll make this 3.2 metres. So yeah, situation where we've got all three sides. Let's work out an angle. Which angle should we work out? Might work out this one here. All right, so let's start with the cos rule formula again. C squared is A squared plus B squared, take 2AB cos C. Now, the issue is that we want to find out C. We are going to do a lot of rearranging here so that I end up with C equals something as an expression. Now, one way that I find, look, just makes this rearrangement a lot easier. You don't have to do it this way, but what I find useful is if you add the 2AB cos C and put it over this side and take away the C squared from this side. So essentially to both sides, we're going to take the C squared and add 2AB cos C. I'm going to do those two things at once, which is a little bit weird, but essentially all I'm doing is I'm moving that 2AB cos C over here and I'm moving the C squared over there. It just ends up being cleaner after this point because you don't have to deal with as many negatives and rubbish. So what that gives me is 2AB cos C equals A squared plus B squared take C squared. From there, it's 2AB times cos C. So the opposite of multiplying by 2AB is, of course, dividing by 2AB. So if I divide both sides by 2AB, I'll get cos C is equal to A squared plus B squared take C squared all over 2AB. From there, I want C by itself. The opposite operation to cos is, of course, inverse cos. Cos is -1. That allows us to get a pure expression of C is equal to cos -1 A squared plus B squared take C squared all over 2AB. I like doing this algebraic stuff first. You should get that formula every time. Every time you're after an angle using the cos rule, if you don't get something that looks like that, something's gone wrong, right? Now, before I can put in all those values of A, B and C, we probably need to define them somewhere. So let's look back at our diagram. We decided that we're after this angle, so that angle has to be C. Remember, we are finding angle C. So if I'm after that angle there, it has to be C, meaning opposite it, that has to be little c. The others, it doesn't matter. We haven't really defined anything there that's limiting it. So I might call that A and I might call that B. So we put that in our formula. So it's going to be C is cos to the negative 1, A, so 19 squared, plus B, which is 14 squared, take C, which is 3.2 squared, all over 2 times A, which is 19, times 14, which is B. So now it is definitely time to put this in your beloved calculator. So, shift cos, and I'm going to close that. I'm going to need to put a big fraction there. 19 squared plus 14 squared, take away 3.2 squared on 2 times 19 times 14. Oh dear. Now, believe it or not, I actually did something deliberate here. Do you know what it is? There's something wrong with that triangle. Try and draw it. See what happens. Give you a hint. It's impossible. The length up here is longer than the length there plus the length there. And if you do that, it doesn't like you very much because you've tried to do something that's mathematically impossible. That's all right. Let's modify the question slightly. So what I'm going to do is I'm going to change that to be 7.2, which is indeed possible because now that length plus that length is more than 19. All I need to do down here is change that to a 7. Look back on our formula. Change it to 7. We get an answer now. It's actually possible to do it. So that gives us C, which is an angle, and it gives us 18.28 degrees. So it's really quite a thin angle when you look at it. Isn't that wonderful? So there we go. We have now done, as a recap, we revisited our old right angle triangle rules, Pythagoras, sine, cos and tan. We then said, well, we're able to go beyond that. We have the sine rule and we have the cos rule that we can use with any triangle. So once we looked at that, we looked at the uses we could do. We noted that the sine rule has 2 angles and 2 sides in it. Allows you to find certain things from other things. The cos rule has 3 sides and 1 angle in it, again allowing you to find certain combinations of bits and pieces from each other. We then proved, we created the rules for the sine rule and the cos rule, which was quite a bit of intimidating fun. We then did an example of using the sine rule to find a side. We then did an example of the cos rule to find a 3rd side, and then we did an example using the cos rule to find an angle. I hope you've enjoyed this and I hope it's useful to you. Cheers.